Okay, everyone, that's working. So home page for settings and document setting. The first thing you want to change is the display digits, the float. So the float is for the calculator page. Okay, when you're adding or solving things, that's the calculator page. How many, I think it's the significant figures, but it doesn't matter. Just change it to a higher value to get enough decimals. For example, the question asks you to give 4 decimals. You need to see at least, I suggest give at least 6 decimal places in case you can do double rounding. So float, like, okay, if you want the 4 decimal places, you need to see at least 6 digits. Okay, 6 decimals. So give a higher float. Like I think you can go for a float 12 or something. Go for a float 12. The next one is the angle. Must put angle under radian. Okay, do not put under degree. If you learn further, like you will ask for degree, but remember to change it back to radian. Most of the time in the question will give you radian only. In year 12, we not use degree that much anymore. So put things under radian. Calculation mode. Okay, this is something important. Put it under auto. Do not put under exact. I know some of you trying to get exact values, but I don't recommend you to put under exact. Why I'm not recommending that? Because when you solve something, the answer is not necessary to be a rational number. It can't always be put into the fraction mode, which means it not necessarily always give you an exact value. Sometimes it just can't give you an exact value. In that case, what will happen is the calculator will refuse to give you an answer, say false or something, or error or something. You just can't get the answer out. So put under auto. Okay, what this auto means? This auto means what format you put in, the calculator will give you what kind of answer. For example, if you put 0.7 times some decimals, your answer will be in decimal places. Like, doesn't matter if it's exact or not exact. But if you put 7/10 instead of 0.7, that is a fraction and everything is in integers, then the calculator will try to give you an exact form, which say fraction mode. So this auto means what you want the answer looks like. You just put your number in that form. Sometimes even though you put exact form, but the answer not necessary to be a rational number, then it will give you decimals. So the calculator will adjust by itself under this mode. So if you want exact, just put fractions and that will give you exact values. If it can't generate exact value for you, that will directly convert that into decimals and give you the right answer. So do not put under exact. That's what my suggestion is. If you really want to, you press Control Enter, you should find the answer, like if you put under exact. But you will stress in exam. So, oh, why is false? Why I can't solve out anything? So it's not safe. So auto is a safe mode. So 3 things need to change: the float and the auto and the angle. 3 things you need to set correctly. So I'll press OK here. Then the next thing is for graphing. If you can enter into the graph page, okay, where you sketch the graph, you know sometimes you want to read intersections or like turning points from the graph, right? Like the maximum, minimum. The float is like decimal is 2 little decimals, like just 2 decimals, 3 decimal places. Where you need to change is not that the previous page I'm showing you. You need to go menu here and number 9 setting and change the float inside the graphing page. Okay, I have a float 7 here. Or I can put in a higher float, like float 9 or something like that. And radian mode as well. Okay, geometry angle don't need to worry about that. We don't really use that. But graphing angle must be radian. Give a higher float, like whatever, like 10 or 12. Well, not to be too many, because if you put too many, it can be slow the calculator down, because calculator trying to give you a like more accurate value. So 9 will be good, but it depends on the question. If the question says 2 decimals, 9 is quite enough. Press OK here. So 2 things: the top 2, the float and the radian for the graphing angle. Another thing, if you can see, okay, I'll show you again, under the float, and there's a fix. Can you see the fix 4, fix 5? Well, seriously, I don't know what that exactly means, but when we will use for that, you know, last year there's a SAC question, and then there are two functions trying to solve to, I think it's trying to solve, like equalize them and trying to solve for intersects. Quite like a large number of students, the calculator stuck. Okay, just like turning, like say calculating, and then stuck. And then needs to restart and press the back to restart the calculator and try again, freeze again. It can't work. It just can't solve out the answer. There will be another way to solve for it, but like that will be the most straightforward way. Most of the students will do for that way. That's the last question of the SAC. And then it's not working, and then everyone just give up. And then what I learned from that, I don't know when I did that SAC because I used another method to do it. But after that, I know if you change your float to, because most of the students' float is quite high and want to give more decimals, that's why the calculator stopped working. So if that happens, first thing, try to change another method if you can. Second thing, if it doesn't work, you really need to solve that equation. Change the float in the front page, not the graphing one, like the calculator one. Change to a smaller fixed float, like fixed 2 or fixed 3. Then the calculator sometimes can work for you. So you change your float to lower decimals, and then it's easier to calculate for the calculator. So it's still, sometimes, most of the time, it should work. So that question, I think, is changed to a fixed 4, and then it start working. So the laptop in my computer is a little bit different from the one you're actually holding, because my one is more powerful. So that function I put in my, I didn't use that calculator, I used my laptop to solve, and it's very easy to give me an answer. But in the calculator, it will freeze quite often when you solve like really complex equations. Then you need to change the float to fix something and then to make it work. Or change another method will be the best way. Okay, so the exam question, it definitely can work. Okay, a lot of people has a test for it, so it definitely can work. It's just not, either you're not using the right method or your calculator got something wrong. So try those two things. So that's for the settings. That's for the settings. Okay, back to the question. Okay, let's think about the question now. We have the first one. Okay, the first one is a really easy question. I get that from the year 11 book. Get that from the year 11 book. But this question is important because we're trying to investigate on domain. So you need to know how to solve for domain. So a rectangular piece of cardboard has dimension 18 times 24. So if I can draw a rectangle 18 times 24 centimeters, 4 square, each x has been cut, removed from the corner. So this is a really, like, this type of question really start from year 10 and keep going on. It's quite boring for me, but like we cut in that way. Okay, so disappear, 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 disappear. They all got the dimension of x, and if you can fold that through the dashed line, you can make a rectangular box. So we want to know the V, the volume, and then state the domain for the function. So if we think about the volume, it will be base times length times width times height. So the length will be 24 minus 2x, and the width will be 18 minus 2x. Then the height must be x. So I will go for that and times x. Well, you can expand it to make it expand form, or I will just leave like that. So that's the volume equation. The important thing for this question is talking about the domain. So if it's an actual measurement or geometry question, the domain will be only one thing. So it's the length. Okay, your length can't be negative. So if it's a measurement or like papers or objects, so the requirement is your length can't be negative. Like all the lengths can't be negative. Okay, so actually should be the volume can't be negative, but if all your length is not negative, your volume can't be negative, right? So you need to think about all the dimensions. So for the dimension for rectangular box, we have like length, width, and height. So my 3 inequality will be 24 minus 2x must be greater than 0. 18 minus 2x must be greater than 0. And the x itself needs to be greater than 0. Because we need some length, we need some width, and we need some height. Okay, we can't just cut nothing. If you cut nothing, it can't become a rectangular box. You want to make a box, we need to left something with the length, width, and height. So your length will be 24 cut 2x down. The other side is 18 cut 2x. So you can't cut too much. Like say if we cut a 15, nothing left. Okay, so we have nothing left. So there's no box at all. After we solve that, we should have x less than 12, x less than 9, and x greater than 0. So we have 3 inequality here. Again, I need to satisfy 3 inequalities. Okay, I must have the x set satisfy all these 3 inequalities. Therefore, we are trying to find the intersections between those inequality. So if you think about, we draw a number line. We have 0, 9, and 12. I need x greater than 0. I use the red line. I use the black line to show x needs to less than 12. That's here. And then I use the green line to say x is less than 9, which is here. You can see the intersection where we have 3 colors will be from here to here. Okay, that's where we got 3 different color lines. So that's the intersection. That's the set what we share. So the x needs to belong to 0 to 9 exclusive, because we need some height. My x needs to be greater than 0. Needs to less than 9 because we don't want to cut the whole width. Okay, so we can't cut everything. It needs to be a little bit less than 9. So that domain will be x belongs to 0 to 9. That's how you find the domain. Okay, it's an easy question, but the idea is what you need to think about to find the domain. If it's a measurement question, what you need to think about is the length. Okay, length can't be negative. If length is not negative, your area and your volume can't be negative. So that's where you will start to do this problem. Any questions for that one? Okay, if not, we'll go to example 2. Okay, that's one question I get from some trial paper, I think, or exam paper even. So let's have a look. Victoria James is a spy. Okay, so there's a mission on an island. If you can see, that's the shape of the island. Okay, that's the shape of the island. Traveling in a hot air balloon. So, well, you want to fly over the island. So that's the balloon. Her flight path is observed from a stationary ship nearby. So something stationary here and observe the path. The height b in meters of her balloon above the sea level when is x meters from the western edge of the island, which is here. Okay, so that's is given the edge of the island, and that's the give you the height. Okay. Okay, that's the edge of the island, and then you talk about the height. Okay, that's the edge, and you talk about the height. So bx is given by that equation. Okay, first of all, did you realize what kind of equation is that? Like, what's the name of that equation? Parabola, like quadratic. It's a quadratic, it's a parabola. So we have domain 0 to 3000. Okay, that's the bx, and the graph of y equals to bx is shown on the diagram already. Okay, and then from the ship, the length L in meters of the land above the sea level of the island, x meters is from the western edge. Like, we measure from that point. Okay, we say we increasing to that way is increasing that distance, and then we talk about height here. So the height L is those lengths. Okay, those height. Okay, that's the height of L. So we are talking about the height of the island. So measure from here. So it gives you another equation here. Okay, what kind of equation is that? What kind of equation is that? That's a polynomial. Okay, that's a polynomial. That's a linear. The second bracket is a linear. The third bracket is a quadratic. So I think it's a quartic if you can expand it. That will be a quartic. So it's just two simple polynomial questions. Okay, your equation is actually two polynomial functions. Okay, when you see this complex expression, what you will do in your exam is define the function in your calculator. Okay, define the function in your calculator. So I will define that. Okay, do not use the top calculator and graphing the scratchpad. No, just use this. Okay, there will be some problem. I don't know why, but I see students using the top one and the answer just not right. It's very strange. The answer is just not right. So use the bottom two, those two functions, graphing and calculating. So calculator here. So to put that into the I forgot to take my notes. So x over. Can I borrow paper? No, actual paper. Okay, so I'll put negative x squared over 2000 plus x over 10 plus 200. I'll go control and VAR, the button above 9, to make this arrow. I know you can define this through menu action something, but like it will be quicker. Just control VAR, define the function already. Give a name of that function. I will say that's a bx, just the same as the question. B bracket x, like make sure your variable in the bracket will be the same variable in the front. And press enter, that will be done. Okay, you finish. Every time you recall b, that will be that function already. So Lx, so x over 10000, put times. Okay, make sure you put times. Sometimes it will go wrong if you don't put times. X over 1000 times x squared over 1000 minus 3x plus 4000. Control VAR, this is Lx. Hopefully I haven't typed things wrong. Okay, that's the Lx. Okay, so we have finished that. One thing I want to talk about, okay, can you see like this is where you're typing? If you make a mistake in the front, you can go Control and 7 to make it directly jump to the front. Okay, that's some quick, like just some tips for you. So you can directly make it jump to the front to edit like where you make mistake from front, not go left. And you go Control 1, you will jump to the back. Control 1 will jump to the back. Okay, so where you're editing, the line you're editing, you can jump from the front to the back. Control 7 is go front, Control 1 is jump to the back. Okay, so we have defined the function. Now let's have a look at the question. What is the width of the island in meters as observed from the sheet? So the width of the island, you can see that's here to here, which is the 2x intercept. So this point is already at 0, 0, because if you sub 0 into the Lx, that will be just 0. So the width on the other side, I need to find that intercept. So because we have defined the function Lx, what we can do is just go for menu, 3 and 1 to solve for it. We don't need to put the whole function now. We just go for L bracket x equals to 0, comma x. Okay, move where you're editing outside the bracket. Go Control equal, get this bar. Okay, which restrict your domain. Your domain is only I don't know the domain. Have it got? Do I have the domain? No, not yet. Not the L. So I don't need to restrict it. Just solve for 0. Sorry, comma x. Forget that equals to 0, comma x. Okay, that's what we're trying to solve. We want to solve that function equals to 0 and comma x. So for that, we got 0 and 2000. So 0 and 2000. You will have the width of the island as 2000 like meters. Okay, next one. Find the coordinates of the point where the height of the island is a maximum. Express these coordinates correct to 4 decimal places. So I want to find the maximum point here, which is the turning point. So we can see that from the graph. Okay, we can see that from the graph. So if you can go to the calculator. Okay, go for height f1x. You have defined it. Go for Lx. And remember to define it because it's only for 0 to 2000. Control equal the bar and go for 0 less or equal to x less or equals to 2000. Go for enter. I can't see anything because I haven't adjusted that. So go for window setting. The minimum is 0. The maximum I will just put 2000. Minimum is 0 and maximum I don't know what's the maximum. Let's put 5000. I don't know what is it. Oh, it's too large. Like 41. Go for 500. Yeah, that's better. So I can see the function now. I can move that away. Go for menu, trace graph, and for maximum, left, right. Okay, I got enough decimals. I need at least 6 decimals. That's enough. So that's the maximum. We just copy that down. 695. 695.5192. And then 2174949. Coordinates of the point where the height of island is a maximum. Okay, that's the maximum. Express the coordinates correct to 4 decimal places. That's what we get. That's B. Okay, have a look at C. C said find an expression for dx which gives the difference in height between the balloon and the island in turn like for x. So the dx must be the balloon is higher minus the height of the island Lx. So you just use the dx minus the Lx because for the same x that's the height of the balloon and that's the height of the island. So you just subtract between them. So it's bx minus the Lx to give you the distance between them. So I can go back. I can say bx minus Lx okay, go for enter. Well, I got a really like long and terrible expression, but it's okay. You just copy that down. I'm not going to copy it for you. Just copy that down. Also remember to define the new function. Yes? Yeah. That's alright. If it's right. If you got enough, like zeros, that's fine. So control VAR, that's a new function called dx. D, where's my D? dx. Enter. So now I have defined a new function as well. Okay, can you see that is actually the difference between two functions? So the next question is asking what's the domain for D? That is 0 to 2000. Remember the domain will be the intersection between the two graphs. So for Lx, domain is 0 to 2000. For the balloon, the intersection is 0 to 3000. So the intersection between them will be 0 to 2000. That will be the domain for the what is called the domain of the new function dx. So subtract or addition or product or divide between functions, we will find the intersection between each function, and that's the new domain. That's what we just learned. Okay, next one. Find the minimum vertical distance between the balloon and the island Express the distance in meters correct to 2 decimal places. Okay, in meters expressed to 2 decimal places. So if you go to the calculator, I can still do by this way. So you go tab. So we want to draw dx now. Okay, can you see that's the dx shape? Like that's how distance changed. So we can find the minimum here. Okay, that's the minimum distance. Go for menu 6 and minimum. That you need to click on the graph because there are 2 graphs. Okay, we click on this graph. Menu 6. Graph. Lower bound equal left and right. So that's the minimum, and move it a little bit higher. 626.5. How many? 2 decimals. 626.59. 26.78. So it asks you to find the distance, the minimum distance. So the minimum distance is this much meters. Okay, that's the minimum distance. It's all by calculator. It's the y value. The x value tell you where the minimum distance will exist. So go over 626 meters from the horizontal, you will achieve the minimum distance. Calculator. The coordinates. That's the horizontal distance. You don't really need that value. You don't need it. What you need is only the y value. So what is the actual distance? So this 626 gives you this balloon traveled to here 626. Then you got the distance of 26.78. Okay. So the balloon traveled to 626 point blah blah. You got a distance difference here 26.78 by graph. I have sketched the dx. That's the dx graph, the distance graph, like the difference between the distance. That's the graph for dx. So that's the minimum. By using menu number 6, number 2 for minimum, search for the minimum, and that's the lowest distance I get. Yeah. Okay, next one. The enemy fires a missile from the launch site located at the point 1,200, hoping to hit the balloon. Okay, the path of the missile is straight line following the line of the tangent of the graph y equals to lx at the same point. Let's have a look. Where's 1,200? Okay, the enemy is here. Okay, it says that locate at the point, like you must be on the island and fire something. You can't in the air and then fire something, so you must locate on the island. Or if you want to test for it, you can calculate L 1,000 give you 200, which shows you that it's on the island. 1,200 is a point on the island. And then hope to hit the balloon. The path of the missile is a straight line following the line of the tangent. Find the equation of the path of the missile. So tangent, what's the tangent looks like? The tangent will be that line. Okay, that's the tangent. I use the blue color. Okay, that's the tangent. Okay, be quiet for the next 5 minutes because I will go through a lot of calculator thing. Okay, learn for that. So you know when you study tangent, that's the differentiation, the gradient at the point 1,000, right? So we want to go through the differentiation. I want to find what's f dash 1,000. What's f dash 1,000 to find the gradient? That's the gradient of this line. That's last year's thing. But we'll go through that again when we learn chapter 9. However, you should know the tangent of the graph the gradient will be the differentiation of that point. Okay, now in the calculator, first of all, you want to do differentiation. The differentiation is d dx. So how to find d dx? Normally you find it in some button next to 9. But there's a quick button. If you can press the shift button and the minus button, that will directly give you the differentiation sign. Shift, which is above 7, minus is just a minus. Okay, shift minus, you will have the differentiation function directly out. Okay, you call that directly. Shift and minus. Shift plus will be the anti-differentiation. Okay, shift plus will be the anti-differentiation. So if you go shift plus, you can try. Shift plus is the anti-differentiation sign. So you want to d dx of which function? You want to d dx the Lx function. Okay, you go for Lx inside. Okay, Lx inside. That's the derivative function. But you don't want to substitute things. X, change the x for 1,000. So what you can do is, after you d dx that, you directly control VAR to give another name of your differentiation function. Let's call that L1x. L1 bracket x, because you already use L. So I will define the differentiation function of L by L1x. Press enter. That's a new function. That's the derivative function of L. So I'll go for L1 bracket 1,000. That's the derivative value, like the gradient of that point. That gives me -1 on 10. -1 on 10. All of this is on your calculator. You're not showing any of this line in the actual written question. Like, that's not part of your answer. This is all the process you did in the calculator, only shown in the calculator, not on your actual paper. You're not going to write this down in the paper. Okay? You're not going to write the calculator language in the paper. Do not write any line in the paper, actual paper. So what I can write is L dash 1,000 equals to -1 on 10. L dash 1,000 equals to -1 on 10. So the equation will be y minus y1, which is 200, equals to the gradient x minus 1,000, which is x1. Y minus y1 equals to the gradient x minus x1. That's the linear equation. You know the gradient of the linear, you know a point on the linear. The point will be the touching point, 1,200. That's the linear equation. So y equals to -1 on 10x plus 100. Plus 100 and then plus 200, so plus 300. That's the linear equation. Expand, and move the 200. Okay, the bell about to go, but let me finish F and then I will leave E to tomorrow. Okay, let me finish F. Find the coordinates of the points where the missile will cross the path of Victoria's balloon. So if you go to see the Victoria's balloon, the path, they not actually hit Victoria, but it will go across the path, okay? So that's the path. So it will cross the path at that point. So it's very easy to do is to solve y equals to -1 on 10x plus 300 and the y equals to bx, the balloon, okay, the bx, y equals to bx. you solve that simultaneously. So menu 3, 1, y equals to negative 1, let me finish showing that, 1 on 10, menu 3, 1, negative 1 on 10x plus 300 equals to bx. Directly type bx because we know what is bx, and comma x. So we have exact values. Well, if you can see, that's a control and enter. This is 3,000 something already. That value is 3,000 something already out of the domain. Okay, it's out of the domain, so you don't have that one. So that will be the intersection. Okay, that will be the intersection. But you need to keep the exact form for it. Okay, keep the exact form for it. I think it's not asking for decimals, no. So you need to keep the exact. Is negative, so negative 1,000 times root 2 minus 2, comma, you need to substitute that point. Okay, so I will highlight this bit. That's my answer. Control C is like the copy function. So boolean B bracket control V to paste the value into that. Okay, so I want to find the Y value. So that gives you 100 root 2 plus 100. That's the coordinates. That's the coordinates that the path and the missile will cross to each other. So that's where they intersect. Not the x. It's still positive. It's still positive. That's 1.4 minus 2 is still negative. Negative times negative is a positive. Why I take this one is that it's outside domain. My domain is 3,000. It's outside domain. I only take 585. That's still a positive number. That's why I press Control Enter here to see what's the value of about. I'll leave the next question, last part. It's a hard question for the last part. Try that tonight. Try to think about it. Now you understand the question. Then I will go through the last exercise with you tomorrow, the start of the class. And the rest of class will be revision.